Today we are going to go over the primitive data types in C and how we can extrapolate those into C++ to make development easier and smoother. C++ is the child language of C, so C is the parent language. And what that means is that C++ is an extrapolation upon C. And to understand C++, we need to understand the basics of C, so that's what we are going to review. Now, this is technically a beginner's tutorial on how to use variables in C and C++, and how to program variables into your code and how to use them. Now, these are the four primitive data types of C. Every other variable type is extrapolated upon these four. Now, there are some exceptions to that rule, but for the most part, these are the four core data types, and you can do pretty much everything with these four. Well, the first data type, character, is defined like this. So I'm going to write, sorry, my computer is lagging because of the broadcasting software, but that's C-H-A-R. Now that is short for character, right here. And I like to call it char because it has a better ring to it than char, which most people call it, or character. So when I say char, that's what I'm referring to. So we're going to say char space, and then we're going to give it a name, and we're going to call this name variable 1, and then we need to just end the line with a semicolon. And what this is a declaration of a primitive data type in C and C++. It works in both languages. It's completely valid. And this is very simple. We just have the type specifier char with a space and then the tag name. This tag name is used so we can reference it from throughout our code, so we can use it. But this is not necessarily good practice. Now, the reason why this is not good practice is that this is an uninitialized variable. And what this means is this variable's value, we don't know it. And that is a problem because that can cause undefined behavior if we accidentally use this variable later in the code. And it also helps for readability when we assign it right when we define it. So to initialize a variable, you would just put a little equal sign. And what this is a set operator. And we are saying to set variable 1 to the contents of whatever we type right here. And what we're going to type is we're going to assign a character. Now, I'm going to use single quotes to surround this character. And the reason I'm using single quotes is that if I just put A here, it's going to look for a variable called A and try to set variable 1 to the value of A. Well, we don't have a variable called A. We're trying to set it to the character A because it is a character data type. So we use these single quotes to tell the compiler and tell the language that, hey, we're setting a character. We are setting the value of A to variable 1. And that is important to note that we need to use single quotes, not double quotes. So I'm just going to zoom in on this so you see clearly what's going on here. And there it is, it's single quotes, and then we have the capital A. Now, this is different from setting it to the value lowercase a. It's completely two completely different characters. Well, so for now we're just going to set the capital A, and this could be a symbol, this could be a number, but it can only be one character. So if it's a number, it's 0 through 9. If it's a character, it's A through Z, capital or lowercase. If it's a symbol, it's one of the ASCII symbols. So, moving forward, this is the basic declaration of a character variable. And this declaration type is the same for all data type declarations in C, pretty much. So, when we just have the type specifier, the tag name, and then we initialize it to a value, dependent on what type it is. So, we're just going to do a quick floating point example here. And a floating point is denoted by float. F-L-O-A-T. We're just going to call this variable 2. And the reason we're calling this variable 2 instead of variable 1 is because we can't use variable 1 again, because if we use variable 1 in the code somewhere, it won't know which one of these we're talking about. We need to have unique type names. So we call this variable 2, and we're going to assign it to 0.0. And the reason why we're going to assign it to 0.0 is floating point is a decimal number. So if you need to store a decimal number, and when I say decimal, I mean it has precision after the decimal point. It's not a whole number. If we want to use decimal numbers, and this is a whole host of cases where you need decimal numbers, you use a float to store that data. So this creates a variable and stores a value of 0.0 in it. And now we're going to move on to integer. So for integer, this is just int. Int is a type specifier, and then we're just going to call this one variable 3, and we are going to set it to 0. Now, I can't set this to 0.0 like I did with the float, because an integer, as in math, is a whole number. It can be negative or positive, and it has to stay within the range of negative 2.14 billion to 2.14 billion. So that is negative 2.14 billion. Now this isn't exact. This is, I'm rounding here to 2.14 billion. So those are the numbers that you could store. So I can store 1,000,005, but I can't store 3 billion inside of an integer. The reason for this is because an integer is 4 bytes in size, and you can only store so much data in a certain amount of space. And in C and C++, integers are 4 bytes. Keep that in mind, that these variables have sizes. And the size of the int, 4 bytes, restricts us to this range. So, if I wanted to store a whole number in this float, I can do that fine. I can set this to 0, but it's going to be represented as 0.0. And if I try to set it to 2, it will be represented as 2.0. It will always add precision. Now, if I do an int and I try to set this to 2.4, it's actually going to be represented as 2, because it's an integer. It doesn't have precision. It doesn't have anything after the decimal point. It is a whole number, negative or positive, within negative 2.14 to 2.14 billion. So if I try to set this to a floating point, it's going to truncate it. It's going to drop the decimal points. It's going to just ignore everything to the right side of the decimal point. So our final primitive data type is the double. And the double, you can just represent it as the name double. I'm just going to call that variable 4. And that we're going to set equal to 0.000000. Now, the reason I'm setting this equal to so many zeros on the end is that a double is double the precision of a floating point. So it is also just a decimal number, and it's how you store decimals, but it has very high precision. But it is twice the size. A double is 8 bytes. I'm just going to mark these with their byte count. That's 4 bytes. And a float is 4 bytes too, same as an integer. And a character, as you can tell, is just 1 byte to store 1 character. But the reason why double is twice the size of these two primitive data types and 8 times the size of a char is because it stores double the precision of a float past the decimal point. So what this allows us to have 4 bytes to the left of the decimal point and 4 bytes to the right. And what this does is it creates a very, very complex number that we can store here. This is for high precision calculations. When you're using a double, you are dealing with like 0.000000096, while if you try to store that number in a float, it would probably truncate it to 0.000. You would lose that precision. So float is for kind of like low stakes but precision calculations, while a double is for high stakes, high precision calculations. An integer is just for whole numbers, and a character is for letters, numbers, and symbols. Those are the differences between the 4 primitive data types of C. Now, why would we ever use float if we could just have a higher precision version in double? Well, that's because the size is twice the size. And if you saw the previous video, I recommend you watch it, on memory. Memory is important that we save memory, especially on systems that we don't have a lot of. And when we're dealing with programming, we can be allocating millions of variables, and millions of variables becomes millions of bytes, and millions of bytes becomes megabytes and gigabytes that would be twice the size if you used a double versus a float. So if you don't have to have high precision, it's recommended that you use a float, and only use larger primitive data types like the double when absolutely necessary. Alright, so what we're going to talk about is we're going to talk about how to use these variables in code. And the way we use these variables in code is different from how we define them. So here we've defined this variable 1 character, and to use it, we don't have to specify that it's a char because it's already been defined as 1. We can just reference it typing variable 1. Now variable 1 is that up there, and I see that I've double highlighted these right here. So it is referencing this one, and the compiler knows that, hey, this is a char. So we can go ahead and set it to a different value. We can change it Now there's a whole host of reasons why you would do this in code, but we're not going to get to them now. That's what you can do with a char. You can easily change it. And right there, and we can do a lot more things with it, but we're not going to get into that today. So that's how we can just manipulate a char, just simply like that. Now if we're talking about the float, variable2 right here, we can type variable2 equals 2.0. And we've changed the value of variable2, which is a float, from 0.0 to 2.0. So now variable2 holds 2.0 in it. And we can actually do some weird tricks with this too. We can do adding 1.0 right there. And I'm sorry, I forgot the 2 right there. So what we're doing right here is we are taking variable2, which was originally 0.0, and then on line 22 we changed it to 2.0. And then on line 23 we added 1.0. This is the add operator. We added it to the current value. So if the current value was 2.0 and we added 1.0, variable2 now holds 3.0. Now, this is important to understand the add operator. Now what this does is I'm going to break it down to you in a very easy way to see. This same line is the same as this. Variable2 equals variable2 plus 1.0. These are equivalent. Right here, this and this is the exact same thing. Because what we're doing here is we're using the add operator to add 1.0 to variable2. And here we are setting variable2 equal to the value of variable2 plus 1.0, which is the same thing as adding 1.0 to variable2, then setting the result to variable2. So these are equivalent, and you need to understand that. Alright, so you can also do division, which is just going to be / equals 1.0. That's just going to divide by 1. And you could do the same thing by just replacing this with a division symbol. Oops, that was my syntax highlighting. So this is just showing that you can divide, and these are equivalent. Same exact thing. And you can also multiply by just using this little asterisk symbol. And right here, we're just going to use the asterisk symbol right there. So these are equivalent. They both multiply variable2 by 1. And then we can use the minus symbol if we want to subtract. And those are our 4 mathematical operations, core mathematical operations, on the floating point type. Now, this applies to floating point. It actually does apply to char, but I'm not going to explain how that applies to char because that's going to confuse you. But in terms of mathematical operations on numbers, what we did here with the floating point, we could absolutely do with our integer right here. So if I just copied this real quick, and I just changed all this to variable3, and what I'm doing is I'm just copying, pasting, and I've changed this to variable2 to variable3. This is not going to throw an error. This is perfectly legal. We can do mathematical operations with an integer the same way we do mathematical operations with a float. They are both numbers. And you can absolutely just take variable2 and equals variable3 plus 2. So what this is going to do is it's going to set variable2 to the value of our integer, variable3, plus 2. So you can do mathematical operations incorporating both a float and an integer. They are completely compatible to work together. And this all applies for double too. Double can be done, mathematical operations can be done on a double the exact same way that we do mathematical operations on variable3 and variable2. Now this is important to note, because this is language wide. Math is the same with all numerical type variables. So 3 of our primitive data types are extremely compatible, and char is actually compatible with all of them too, but I'm not going to explain the little tricks to make that work right now because it's not very necessary. Regardless, this is how you define a variable in C and C++. These are the 4 primitive data types of C and C++. This is how you would use them, and these are the mathematical operations you can conduct with them. That's all for today. Thank you so much.